Hello, Mr. C here. This is the first Zoom meeting for this week, section 4.5, week of January 25th to 29th. We're hitting 4.5 this week, which ends chapter 4. So no quiz this week. We will give test 1 on Friday this week, and it'll be due Sunday. Same format as the quiz, and it will have these 5 sections on it. I will mail out, there'll be a practice test sent out, and I've already done that, and it's not for a grade. I'll have problems all worked out. Okay, the actual test will have problems all worked out. And you'll enter true or false depending on whether the problem is correct. You'll only be allowed 1 submission only on test 1. All right, you won't receive an immediate grade. I will set a cutoff date. Test 1 must be completed. I will not accept any submissions for test 1 after that date. This is to prevent students from using non-UNG emails to puzzle out what the answers are, and then cheating by using their UNG email to submit a correct test. All right, but we'll give more details on that at the end of the week. For section 4.5, practice problems, not for a grade, page 404, problems 3 to 37 and 49 to 53. Problems are on test 1, but we have no specific quiz over them this week. Right, the web assigned assignments, again on your personal study plan, chapter 4, section 4.5. Practice quiz, problems 1, 3, 4, and 5 only. Just email me the percent of these 4 problems that you get correct. So what we're going to do today is try to get you started, give you some examples. Section 4.5. Exponential and logarithmic equations. And so what we're doing is we're solving these equations. So you undo what is shown. So if you show exponential, you do a log, or you take the log. If you show log, you take the exponential. And they've got both types of equations in this section. All right, so just give you a few simple examples before we hit some book problems. Let's say we want to solve e to the x equals 3. So what we do is we take ln, both sides. ln of e to the x is equal to ln of 3. These undo. This is called the exact answer. And the book will ask you for some exact answers. Exact answer. It will also ask you for an approximation to ln of 3. .0986. I can do a check. Sub this in e to the 1.0986. It won't come up exactly 3. There's a round off here, but we'll see how close we get. E 1.0986, 2.9993. So we're doggone close to 3. All right, and I guess I'm slightly short on paper. Let's see. Second type is, let's say, solve log of x equals 3. So now I want to take e, both sides. Raised to the ln of x equals e to the 3 on this side. X then, because those will cancel, e to the 3. And again, that's an exact answer. You can see the check. If I plug e to the 3 back in, does indeed equal 3. 3 equals 3. The approximation three 20.0855. Okay. Then, of course, you go to other bases, which the book starts with. And more steps. So we'll start on page 404. I guess we'll start with a problem like number 3. Page 404. Problem like number 3. This first section is cooked. Problem 3. First section is cooked with tricks. So problem 3 says solve 5 to the x minus 1 equals 125. Well, I guess we'll call it method 1, cooked. Meaning you're supposed to notice that 125 can be written as 5 to the 3rd. So in actuality, you'd have 5 to the x minus 1 equals 5 to the 3rd. See how the 5s are the same? So you can set x minus 1 equal to 3, add 1, and you get x equals 4. All right, now that's, fine. It's pretty quick. The only problem is it only works with this exact problem. With this one exact problem. So I don't like this. I like to stick to methods that work every time. Stick to methods that work every time. So I like LN. We'll call this method 2, the LN method. The LN method. So I'm going to solve minus 1 equals 125. And I'm going to take LN. both sides. Ln of 5 to the x minus 1 is then equal to ln 125. Okay, now at first glance, this is probably considered very stupid. Ln is base e. Base e, it does not undo base 5. But we have law 3. Under law 3, I can write this as x minus 1 ln of 5 is equal to ln of 125. Now, I could distribute the ln of 5 through, but I prefer not. Usually just divide by it because it's a nasty number. You can punch it on your calculator. You divide by it, you wind up with x minus 1 then is equal to the log of 125 divided by the log of 5. And now all you have to do is add 1. And add 1, and that's the exact answer. All right. It's supposed to work out 4. Let's get the approximate answer then. ln 5, my fault. ln 5. And then add 1. I like a drum roll. In normal class, I'd ask for a drum roll. I like a little bit of drama. We hit the enter, and sure enough, there's your 4. Now, yeah, it's a little longer than the other method. But to me, the advantage is that you don't really have to, it takes the thinking out of it. If I see an exponential, I use an ln. The only log you need, ln. You can do all problems with ln, all exponential problems with ln, with natural log. That's the advantage of it, and it's on the calculator. So you don't have to be, I hate methods that, well, in problem 3, use this trick. In problem 4, use this trick. Problem 5, use this trick. Don't like that. Then you have to memorize, well, which trick goes with which problem. Don't like math. Don't like doing math that way. Like math as simple as possible. Use the same method every time. At least that's the way I prefer it. Why don't we try the next one, number 5? I guess I'll split it. We got number 5. Oh, it's the same base 5. Why don't we go to number 9? Solve 6 to the x squared minus 1, 6 to the 1 minus x squared. Yeah, now you probably could see the straight method here. Since the base is identical, you could just set these powers equal. They're not making you rewrite one of the bases like on number 5. But again, I'm just going to use ln because further down the page, it's not going to be as obvious. X squared minus 1 is equal to ln of 6, 1 minus x squared. X squared minus 1, ln of 6 equals 1 minus x squared, ln of 6. Divide again both sides by ln of 6. And on this one, they cancel. And, well, actually on both sides, which sets your x squared minus 1 equals 1 minus x squared. So if you're thinking, well, gee, that's so stupid, you could have seen that. Yeah, you're right, you could have. But trust me, further down the page, they will not be set up that simple. All right, now I hope everybody knows what to do. With x squared, you want to bring everything to the right. I'll just do it one piece at a time. 2x squared minus 1 equals 1. you want to, well, you could bring the 1 over, divide by 10 squared, or we can take factor at minus, yeah, I think I'll just bring everything to one side. 2x squared minus 2 equals 0. You can factor out the 2. X squared minus 1 equals 0. And I hope everybody recognizes your factoring pattern here. X plus 1, x minus 1. Difference of squares. Getting x equals -1 for this one, and x equals 1. Remember, you switch the signs on the factoring. So you wind up with 2 answers on something like that. Okay. Or of course, you can always, I assume everybody knows how YouTube videos work. You can always stop the video and look at something if you need to. All right, well, let's go further down the page where things are not as obvious. So even though 11 is pretty simple, solve. 10 to the x equals 25. Well, once again, I could use an log, log base 10, but I can't. You know, 25 is just a random number. It's not going to work out easy like the first section did. In part A, they want an exact solution. And part B, approximate solution. So I'm going to use ln. ln of 10 to the x is then equal to ln of 25. Right, so, and again, don't cancel these, completely different bases. X to the front, ln of 10 is then equal to ln of 25. And I get an exact solution of ln of 25 divided by ln of 10. Part A, that would be the exact. Now that may or may not be, see, I use ln, I'm not sure what the book is using, so why don't we look this one up. Page, this is 4.5, number 11. Okay. Okay, so this is where things get, I mean, different people can write them different ways. This is the way I do it. Let me get an exact, and that'll be the easier way. On the exact, okay, ln, and they're dividing by ln 10, I'm sorry, 10. 1.3979. Okay, I look up the book. Problem 11A. I'm sorry, 11B. And there is my 4.5, problem 11B, 1.3979. There it is. So I'm matching the B exactly. I don't know if you can get the glare off of it, but you can look it up for yourself. You can barely see it there. That's a little clearer. 1.3979. Okay, but notice 11A, they have 2 log 5. And notice I have something completely different. Oh no, what are we gonna do? Okay, so book, just to show you some of the tricks that come up. B, 1.3979, and I match. Although they did say the sixth place, I just now noticed they said the sixth places. I won't do a true or false based on six places or four places or whatever. I'll try to be more obvious than that. I won't get that ticky. I should be using six places if I wanted to really match the book. Okay, now notice the book, part A, its exact answer is 2 log 5. Okay. 2 log 5. Notice it gives the exact same approximation as mine did. How did they get theirs? I know you're dying to know. The suspense must be killing you. So what they did, 10 to the x equals 25. They used log, and that is legal. Log, you're doing the same thing to both sides. 25. They noticed it was base 10, and so they modified it and used log, which is perfectly legal. I use ln every time. Okay. Now you don't have to bring to the x to the front. The log and 10, they do match, which is why they used it. And then they got log of 25. Well, you can write log as 25 is 5 squared. And then you can bring the 2 to the front, and you wind up with 2 log 5. So there is a different version of their exact answer, different from this. Remember, with change of base, here's another way to change a base. I can write log 25, that's a base 10, as an ln of 25 divided by an ln of 10. If you remember your change of base from 4.4. All right, so you don't have to get the same exact form that the book does to be correct. All right, but your exact form, if you're different from the book, should give you the same approximation. The approximations should match, and that's what proves they're correct, even if they look completely different. All right, why don't we go further down the page? Why don't we try something like more steps? 19, page 404. Solve 300. Got a strange base here of 1.025 to the 12t is equal to 1,000. All right, so I want to divide by 300, trying to get the 1.025, the exponential by itself, and my Wi-Fi is just frozen. It's been working perfectly. It may have just frozen. Okay, caught up. All right, divide by 300. All right, so cancel that, 1.025 raised to the 12t. You could cancel, it would be 10/3. If you want to reduce it, you can just leave it 1,000 over 300. But now I want to do ln to both sides. So ln of 1.025 raised to the 12t is then equal to ln 1,000, 300. 12t to the front. ln of 1.025 is equal to ln, I'll put the 1,000 over 300 in parentheses because that means you are supposed to divide them before you do the ln, so they should be in parentheses. All right, and now you can kind of see I'm going to divide both sides by the 12. They're just coefficients. I Do them both at once by 12 and ln of 1.025. And on this side, divide by 12 and ln of 1.025. And I get an exact answer of ln of 1,300 divided by 12 and ln of 1.025. That probably looks nothing like the book's exact answer. Who knows what they got? I'll just do the approximation. That's all I would, if I were you, I would mess with. Because the approximation should match. Just make sure you get your parentheses right. I got parentheses and 12 ln 1.025. 4.0632. I guess I'll do the 6 places, 0, 2. There's 6 places. All right, I'll check this on the exact. Four, 5, 19. Okay. They reduced their 1,000 over 300 to 10/3. So the top match, I got the 12 on bottom. They're getting a log of 41 over 40, ln of 41 over 40. I can, if you were dying it, but notice my exact match is 4.063202. See both. Frozen again. There we are, 4.063202. So if anybody was dying to know, you can take 41 over 40, apparently divided to get 1.025. How to convert 1.025 to 41 over 40 would be another 10 lines that I doubt you're interested in. What about more, how about one like 35? Solve. 2 to the 3x plus 1 equals 3 to the x minus 2. All right, this is where ln shines. Otherwise, I'd have to do a log base 2 on both sides, and it would undo here, but not here, or log base 3 both sides. Do not do log base 2 of 2 to the 3x plus 1 equals log base 3. I see people do this, of 3 to the x minus 2. So you've done different things to both sides. These are different things to both sides. You violate the rule, do the same thing to both sides. So I use ln. Don't do this if you want a good grade. 2 to the 3x plus 1 equals ln of 3 to the x minus 2. See, I use ln, doesn't undo either one. But I put the exponents in front. All right, now I could get decimals here and here and then multiply through both sides, works. Then you got nasty decimals everywhere. I'd go ahead and just divide by one of them. You can, whichever one you want to use. See, this keeps the nasty decimals to just one side, x minus 2. And now I'm going to get a nasty, I'm not even going to get the exact answer on this one. If I wanted the exact answer, I'd leave this alone. I don't want to mess with that. I'm just going to go ahead and get the approximation. $1.58496. All right, well, now it's just a matter of working 1.58496x minus whatever 1.58496 times 2 is. 58496 times 2, 3.16992. And now it's a matter of just x's to one side, number to the other side, minus 1.58x minus 1.58496x. See, this cancels, moving that over there. 3 minus 1.58496. 1.41504x is equal to, if you can see it, minus 1. I guess I should have showed it, so minus 1 there, minus 1 there. You get a negative 4.992. And final move, 41504 divided by 1.41504. This cancels, and we wind up with our exact answer. Negative 4.16992 and divide by 1.41504. Negative 2.946. There's probably one, because of the approximations, I probably approximated different, rounded different from the book. It probably may not exact to match. There's 6 places. 6A, there's 4 places. We'll call it 5, 7. So that could be slightly different, but it should be pretty close. I won't bother to look it up. All right, well, that's a bunch of exponential equations to get you started. Let's try some log equations. Well, actually, there's a couple more sections here. We can try one like page 404, 39. Let me see exact numbers I used. 3 to 37. Actually, then I jumped to 3 to 37. So that was the first section. And I jumped to 49 to 53. Okay. Okay, so actually, no, that's not on the homework. Let's try 49. Solve. Log of x plus log of x plus minus 1 equals log of 4x. All right, we got to use laws of logs here. There's some tricks to logs when you go backwards that you got to formula. Notice how the two logs are both positive and added. This is why we did those combined problems. So we're going to combine and we get a log x times x minus 1, 4x. Then log is base 10. You got to use the exact base you're shown, or it doesn't undo on logs. So you're going to go 10 to the log x minus 1 is equal to 10 to the log of 4x. Then these undo, giving x times x minus 1 equals 4x. X squared minus x minus 4x then would equal 0, because you have squares and letters. You got to get everything to one side. X squared minus 5x then is equal to 0. Factor out x. X minus 5 then equals 0. Giving x equals 0 and x equals 5. Now, if you quit here and report both these answers, you are very lucky. You have to look for illegal answers. These would be out of the domain. I don't know if you remember from logs, but a log graph looks like this. You cannot put, it's very similar to square root, except you can put 0 into a square root. You can't put 0 into it. That's why it's an asymptote. You must look for answers which make logs negative or 0. These are illegal. And you can see x equals 0, log of 0, log of 0 minus 1 equals log of 4 times 0. This is illegal, this is negative, this is illegal. You only need one illegal. You don't need all three pieces. 0 does not check this. You cannot get the same thing to both sides. 0 is out of domain. But 5 is fine. X equals 5, you get log 5, log of 5 minus 1, 5 minus 1. This is positive, run out of paper, equals log really of 20, 4 times 5. I could punch this on the calculator, it would work. This is legal. X equals 5, the only legal answer, and you need to show me that. Either cross off the x equals 0 or show box the x equals 5. It's the only legal answer. It's the only one I could punch in and get the same thing on both sides. Don't have to worry about that on exponentials because exponentials have domain minus infinity to infinity. You can stick anything into an exponential. So you don't have to worry about illegal numbers. Any answer you get out of an exponential is legal. Any answer you get of an exponential, legal. You cannot spot illegal numbers on logs at the start like you could with fractions. Remember, if I had fractions and I had you solve x minus 1 equals 3, it should be x equals 1 is illegal. So if this was cooked, that you solve this and got x equals 1, you can instantly tell, you put that back here, you're dividing by 0, that's illegal. Logs, you can't tell. You got to solve them out, you got to look at the answer. Oh, 0 makes log of 0, that's illegal. That's a negative, you only need one. I don't even have to check the rest of it. We'll try one more here. Why don't we try number 50? Log base 5 of x plus a log base 5 of an x plus 1, log base 5 of a 20. Same exact idea, you're going to combine log base 5 x times x plus 1, log base 5 of 20. I'm going to use base 5. Log base 5 of x, x plus 1, log base 5 of 20. X times x plus 1 then is equal to 20. These will undo. X squared plus x minus 20 equals 0. See, it's very common on these. You're going to get two answers. Very common, one works and one doesn't. But it's not guaranteed. It just depends on how it's cooked. Hope you recognize this pattern, x plus a 5, x minus 4. Remember, you're factoring on this. Two numbers multiplied to negative 20, add to 1. So 5 minus 4 is your positive 1. 5 times negative 4 is your negative 20. You're getting x equals negative 5 and x equals 4. And And you can see right away, x equals -5 is illegal. If you check it, log base 5 of a -5 plus log base 5 of -5, add 1, your log base 5 of 20. So you cannot get numbers, finite numbers out of these. They're out of the domain. So x equals 5 is illegal. 4 works though. You don't have to write it down. 4 is positive there. 4 plus 1 is 5, positive there. And yeah, you could show us log base 5 of 20. Only legal answer. And that doesn't mean that all negatives are always, it depends on the problem. I guarantee I could make up a log problem where a negative number would work. Okay, so it just depends on, does it make the arguments up here negative? That's pretty much it for 4.5. We're at about a little over 40 minutes. So I hope this helps you get started on section 4.5. And again, at the end of the week, we'll have the test. And we're scheduled for a Zoom session Friday at 8 o'clock. Email me with any questions. We will see you then. Thank you very much.